Welcome to The Explainer, where we break down complex topics into clear, actionable insights. Today, we're diving into something that is absolutely non-negotiable for anyone even thinking about network AI, and that's the quality of your data. And this quote right here, it just says it all, doesn't it? This is the razor's edge we're all walking. It's the one thing that determines whether AI is your network's greatest asset or its biggest, most catastrophic liability. So, how does an AI go from being this amazing, helpful tool to a total liability? Well, it all comes down to a really simple but powerful principle that governs, all of computing, but it is especially true for AI. And that principle is GIGO, garbage in, garbage out. You have to think of this as the absolute iron law of AI. The quality of what it gives you is only ever going to be as good as the quality of what you give it. If you feed it flawed, incomplete, or just plain wrong data, it's not going to magically figure it out. Nope, it's just going to amplify the garbage you fed it, and that can lead to some truly disastrous results. And here's the really scary part. An AI isn't going to tap you on the shoulder and say, hey, this data looks a little weird to me. No way. It will take that garbage data, and at machine speed, it will give you a solution with 100% confidence, and that solution will be 100% wrong. And look, this isn't some abstract theory. We see the fallout from GIGO everywhere. We see it in generative AI that just makes stuff up, or this thing called model collapse, where AI trained on other AI's output just gets worse and worse over time. In our world and network engineering, the stakes are just as high. A single piece of bad data can take down a network that millions of people are depending on. Okay, so if GIGO is the enemy, how do we fight it? Well, it starts with actually understanding what garbage looks like in a network. Before we can fix the problem, we have to know how to spot it. Our data integrity really comes down to these three pillars. First up, accuracy. Does your data actually match reality? Because if a port is labeled server 01, but you got a printer plugged into it, that's garbage. Second, consistency. Is your data formatted the same way everywhere? If you're using 3 different abbreviations for the same interface type across your scripts and tools, that's garbage. And finally, completeness. Are you missing critical context? A high CPU alert is almost useless without the process data that tells you why it's high. That's garbage too. And let me tell you, this isn't just academic. Here's a real, chilling story of what happens when these pillars fall apart. You've got your source of truth, your main database, and it says a critical backup link is down. But in the real world, that link was up, it was active, it was ready to go. So when the primary link failed, the AI, trusting that bad data, just sat there and did nothing. The result? A total site outage that was 100% avoidable, all because of a single piece of garbage data. So, the big question is, how do we stop these disasters from happening? The answer isn't about getting better at cleaning up messes. It means we have to completely change how we think. We have to shift from this sort of passive, we'll get to it documentation to active, strict data validation. This means we have to start treating our data with the same discipline we treat our code. It's an engineering problem. So, here's the checklist. First, you have to automate the input whenever you can. Let the network report its own state to cut down on human error. Second, you have to enforce schema validation. Use tools that literally reject bad data if it doesn't fit the rules. And third, you have to perform periodic audits, using drift detection to find those spots where reality and your database just don't match up anymore. Let's drill down on that middle one, enforcing the schema. I want you to think of schema validation as a bouncer for your database. You programmatically define the rules for what gets in. It checks every piece of data at the door, and if it doesn't meet your criteria, like a properly formatted hostname, it's not getting past the velvet rope. This is that huge shift from passive documentation to active enforcement. It's an absolute game changer. But this quote really gets to the heart of it. The ultimate goal isn't just to get better at cleaning up messes. I mean, trying to fix bad data after it's already in your system, that's like trying to unblur a photograph. It's almost impossible. The real solution is to fix the camera itself, to stop the bad data from ever getting created in the first place. And this shift, from just reacting to messes to proactively stewarding the data, it fundamentally changes what it means to be a modern network professional. It's not just about managing boxes and cables anymore. It's about becoming the guardian of the network's single most valuable asset, its data. Which brings us to the most important takeaway from all of this. The network engineer of the future is a data steward. This isn't just some new fancy title, it's a whole new mindset. It's about taking on the responsibility of curating and validating and guaranteeing the integrity of the network's data. Because in the age of AI, this isn't some side quest, it is the main mission. So, I'll leave you with this question. When you go back to your own network, I want you to ask yourself, is our data an asset that's going to empower AI to do amazing things? Or is it a hidden liability just waiting to cause the next big outage? The choice is yours. And honestly, in the age of AI, it's a choice you really can't afford to get wrong.